Welcome to CW 8.4. We're going to continue our study of polar graphs, and today we are finishing up with roses. So open up your calculator and let's graph our first function right there. 4 cosine 2 theta. 4 cosine 2 theta. Let's go to plot and take a look at that. So as you can see, it looks like a bunch of flower petals, and that's why these are actually called roses. And notice how each petal, there are 4 of them, goes out 4 units. That'll be important. So let's take some time and let's just copy that down. So point the origin, go 4 out on our axes. And do your best to draw these. These are kind of difficult to draw. Okay, so our first graph is now done. Let's try the next one. 5 cosine 3 theta. 5 cosine 3 theta. And this one, you notice now there are 3 petals, and the petals are in a different place. There's a petal on the x-axis, and then there are 2 other ones there. So let's start by putting on the x-axis petal. That's about 5 units out from this calculator screen. And the issue is the other 2 petals, we kind of don't know where they are. Looking at that, it's kind of hard to eyeball it. So a lot of people like to do is they think, well, it must be in the middle, so let's just put a petal, a 3 pi over 4 and 5 pi over 4 like this. But if you do this, we can see this looks kind of funny. And it should. And that's because in these graphs, you'll notice that, if you look at this first one, the petals should be equally spaced, and that is an assumption we can make. So petals are equally spaced, which means we don't want the petals here. If there are 3 petals, let's do 360 divided by 3. That's 120 degrees of spacing, which means our next petal should be at 2 pi over 3, and then 4 pi over 3. And now we'll notice that looks much better. So now we're kind of seeing a couple things. Hopefully you notice that this A, this 4, and this 5, that affects the length of each petal. And this N right here, this number in front, that's clearly affecting the number of petals. Now the next question says, what's happening when N is even versus when N is odd? So you can see N is 2 here, there are 4 petals. N is 3, there are 3 petals. So let's go to our calculator. Let's try to put in 4. So now N is 4. Wow, we can see there are 8 petals. Let's try to go to 5. So I'll change that 4 to a 5. And now I can see there are 5 petals. So let's make an assertion here. If N is even, there are 2N petals. If N is odd, there are N petals. Now you might be wondering, like, why is that happening? Because it seems pretty arbitrary. This is the part that most books and teachers will explain to you. The kind of hidden truth is there are actually always 2N petals. So like on this one, for example, there actually are 6 petals. But what happens is it gets drawn like this. and then it rotates again. So if I do this, notice how I draw 6 petals, but they overlap. So secretly, I'll put a note here. There are always 2 end petals. But if it's odd, we say N because they overlap. So I'll write odd petals overlap. Okay, D. Where do the cosine rose petals start? So that's pretty easy. They all start right here at the 0. Always start at 0 degrees. And then to find the others, we just use spacing. So use 360 degrees divided by number of petals. That equals your spacing. And what if we negated it? So let's say we take this one, -5 cosine 3 theta, or even this one, -4 cosine 2 theta. Let's see what happens. -5 cosine 3 theta. Oh, look at that. It did a reflection. Reflects over the y-axis. So fill this thing in. Cosine rows always have blank symmetry. So take a look at this. We can see cosine rows here, cosine rows here, cosine rows here. They definitely all have x-axis symmetry. Now I'll try the sine roses. 4 sine 3 theta. 4 sine 3 theta. Okay, so we can see definitely one easy petal on the y-axis. So let's start there. And like we said earlier, 3 petals, that leads to 120 degrees of spacing. So 120 from that, from the bottom, should be about pi over 6, I believe. So right here. And then 5 pi over 6. Okay. Now that one's done. Now the last one is 6 sine 2 theta. And this one does not hit any axis point, but we can see they're all in the middle nicely. So let's draw that in. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Yeah, this drawing's not too good. Okay, how are sine roses different from cosine roses? Well, a couple things. We can see that there is no point on our x-axis right here, which means they start at the origin. That's pretty different. But that should make sense since sine of 0 degrees is equal to 0. But I would say the main thing for you to write down is there are no petals on the x-axis. Where do they start? Okay, so we already did that. Start at the origin. And how do you find all the petals? Very similar to last time. We just do 360 over number of petals is equal to your spacing. But you might have noticed that this one we kind of eyeballed. So how can we really know like where it would be? And the trick is going to be to use some basic trigonometry. Or we can even do this one actually. This one might be easy to talk about. The first petal is right here. So right there, there's your first petal. in order to calculate it, you basically just got to figure out when the sine function is at its largest. So you grab the sine function and think about what is the largest it could be, which is 1. Now it's like a regular equation. We'll say 3 theta is equal to, sine is largest at 90 degrees, or pi over 2. So pi over 6 must be your first petal. And we can see that is matching up. So if I wanted this one, I can see my first petal is right here. Do the same thing. Sine of 2 theta, that's equal to 1. So 2 theta should be pi over 2. So theta must be pi over 4. And we're seeing there's our first petal. That's a very easy way to calculate this. So if you like formulas, we can even go a step further. We could say if r equals a sine of n theta, for your first petal, simply do sine of n theta equals 1. So n theta must be pi over 2. So theta must be pi over 2n. And there's a nice formula for your first petal. And lastly, what if we change it to a negative? So let's go to our calculator. The other might be easy to look at. So here's 4 sine 3 theta. Here's regular. Now let's put a negative in front. Definitely reflects. So we'll put reflects over x axis. And now we have a bunch of sine roses. I can say, well, they definitely have y axis symmetry. Okay, now take some time, try to work through these. There's a bunch of practice roses to find the equation of, and then you're going to graph them. I will do one with you to make sure you got it down. So that's the first one, r equals. What I would do is notice that there's a petal right here on the x-axis, which means it has to be a cosine rose. So that's going to be really important. From here, I can see there are 1, 2, 3, 4, 5, 6, 7, 8. 8 petals, and 8 is even, obviously, which means this number must be 4 theta, because 4 would yield 8 petals, since 4 is an even number. The length of each petal is 3, so you can put 3, and this could be positive or negative, so put plus minus. Okay, so finish the rest of the questions and let me know if you have any problems.